Welcome to Mastering Solutions. So I've tried to draw as best I can an equilateral triangle here. And what that means, of course, is that all the lengths of the sides of the triangle are the same. And that also means that all three of the angles inside of the triangle are going to be the same as well. Now you might remember from math class and know exactly what these angles are. But remember, all triangles add up to 180 degrees. So if we take 180 divided by 3, then that of course means that these angles have to be 60. So where they're equal to each other, if you imagine, if we drew a line straight down the middle of the triangle like this, it doesn't want to be straight, but imagine that straight down through, you could see how this line would be perfectly perpendicular to this bottom here. And it's the same thing if we did it on this side. If we drew another line straight through this side, then this is going to be perfectly perpendicular to this line here. You can see how the light ray coming in, this is now going to be our normal, right? It's perpendicular to the surface that the light is incident on. And so we're going to use that in just a minute, but this right here, the angle they tell us in the question, that is 40 degrees. And it's also going to be 40 degrees over here. And so we need to use that, and we'll use it in combination with Snell's law to figure out what is the index of refraction of the prism. So it seems like, how are we going to get there from that, right? But we will. So we're going to create a bunch of smaller triangles into here. This is all just using geometry to figure these out. So if we create a right triangle right here, this is 90. And so now we know from math, this would also have to be 30. So this is a 30, 60, 90 triangle. If this is 30, 60, 90, this is a right triangle as well. So that means this one, this angle right here would also have to be 60 degrees. Now, if we take a step back, remember from Snell's law that the angle is always from the normal out to the ray. So this is also another 90-degree angle. And so if this is 40, then that means that this angle has to be 50 degrees. So you have to be really careful in the Snell's law questions, because that's a really common way that they'll try to trip up students, is they'll say it's some angle not from the normal. And then here, same thing. We found this is 60 degrees, but that's not the angle we need. We need this angle from the normal out to the ray. So we have, again, another 90 degrees right here. So if this is 60, well, this one has to be 30 degrees. So now finally, we have our rays, right? We have our theta 1 and our theta 2. So with Snell's law, n1 sine theta 1 is equal to n2 sine theta 2, and we're trying to figure out what is the index of refraction. And so when we have this here, this is the n of 1. This is going to be the n in the prism. So this n is what we're trying to solve for. So to do that, we simply just need to divide both sides by sine of theta 2. So now we have n1 sine theta 1 over sine theta 2 is equal to n2. The n in this case for 1 is an error, and that's 1, right? So really we could even simplify it a step further and say that n2 is a ratio of sine of the angle 1 over sine of the angle 2. And that makes sense, because what Snell's law helps us figure out is how much light is refracted by a difference of index of refraction. And we can also use the difference of the angle, or how much it's refracted, to work backwards to solve for the n. That might have been a little confusing the way I said it, but if you think about it, we're just using the angles and the index of refraction to go back and forth between each other. So we can plug in our values here to solve for n2, and that's going to be sine of theta 1, which we said was 50 degrees, divided by sine of theta 2, which we said is 30 degrees. So we have sine 50 divided by sine of 30. So the index of refraction for this prism is 1.53. You could round that and say it's 1.5. So it's some sort of material similar to glass. There are some other indexes of refraction, like Trivex, for instance, is one that has an index of refraction of 1.53. Now, we don't know what it is. It doesn't really matter. This is the answer. We have an index of refraction of 1.5.